Hi everyone, welcome to video number 5. Today we're going to be exploring the electronic configuration of ions. In the last video we learned how to write the electronic configuration of electrons in atoms. Today's concept is a bit similar, except we'll be looking at ions. Now, an atom is electrically neutral. The number of positive charges in the nucleus are equal to the number of negative charges surrounding the nucleus in the electrons. Now, some atoms have the ability to give away electrons, which leads to the formation of cations. So cations are positively charged ions. And if we remember in our video about the periodic table, elements in groups 1, 2, and 3 are metals. They have 1, 2, and 3 electrons in their outermost shell, and they tend to give away electrons. So metals will tend to form positively charged ions or cations. Now, anions are negatively charged ions, and these are going to be formed by our nonmetals. So those elements in groups 5, 6, and 7 that have 5, 6, and 7 electrons in their outermost shell, these atoms tend to take electrons from other atoms and become negatively charged. So by giving away, in the case of metals, by giving away electrons, or in the case of nonmetals, by accepting electrons, we obtain a full outermost shell. And if you remember, atoms want to obtain a full outermost shell so that they are stable. So we can demonstrate this. Let's look at sodium. Sodium, symbol Na, has an electronic configuration like this: 1s2, 2s2, 2p6, and 3s1. Sodium has an atomic number of 11, so we get 2 plus 2 plus 6 plus 1, 11 protons in the nucleus of this atom. And also, because we know atoms are electrically neutral, then this also represents the arrangement of the electrons around the nucleus of my sodium atom. So, sodium is in group 1. Sodium has 1 electron in its outermost shell. I can draw sodium like this. So the first 2, so that's this first 2 is this. Then I have 8 in my second shell, and then I have my 3s1. So this is my valence electron. Okay? So what sodium will do is sodium will give away this electron to, for example, a nonmetal that will accept it, and sodium will become positively charged. Okay, so then the electronic configuration of sodium, Na plus ion, becomes 1s2, 2s2, and 2p6. So Na plus is now stable. We have a full outermost shell, 2 and 8. Now we can show another example, and we can demonstrate this same concept using an aluminium ion. So we can show this formation of positively charged ions or cations using another example. Let's try aluminium this time. So aluminium has an atomic number of 13. So we can write the electronic configuration of aluminium: 1s2, 2s2, 2p6, 3s2, and 3p1. This is the electronic configuration of my electrically neutral aluminium ion. Aluminium is in group 3, and therefore aluminium is a metal. Aluminium will give away the 3 electrons in its outermost shell. So I can draw like this, like we've just done for sodium. So I'm going to fill in my electrons, and here we have the 3 valence electrons in the outermost shell. So what aluminium will do when it gives away these 3 is it becomes Al3+. And the electronic configuration of aluminium 3+ cation is 1s2, 2s2, 2p6. Now let's look at something very interesting. The electronic configuration of aluminium 3+ is exactly the same as the electronic configuration of Na+. Now that does not mean that aluminium 3+ and Na+ are the same species. They have completely different mass numbers and they are completely different ions. Okay? The human body needs sodium, for example, to conduct nerve impulses, contract and relax muscles, and to maintain the proper balance of water and minerals. And there is no known physiological use for aluminium. Now, let's look at groups 5, 6, and 7. So now, let's turn to our nonmetals and let's take a look at elements in groups 5, 6, and 7. Let's take chlorine for example. Chlorine is a nonmetal, and basically chlorine will accept electrons in order to become negatively charged ions. So the electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, and 3p5. So we can draw chlorine like this. So we have 2 in the first shell, 8 in the second shell, and 7 in the third shell. So 2 here, 8 in the second shell, and then 7 in the third shell. So chlorine, as you can see, just needs 1 electron to complete its outermost shell. And therefore, chlorine will accept an electron from some other element, most likely a metal. And in that case, chlorine will then have an electronic configuration like this: 1s2, 2s2, 2p6, 3s2, and 3p6. So this is the electronic configuration of our Cl- ion. So all that's left now is our group 4 elements. Remember, we have looked at groups 1, 2, and 3. These are my metals, and these will give away electrons to become positively charged ions. Groups 5, 6, and 7, these are my nonmetals that will accept electrons to become negatively charged ions. Group 4. Remember, the group number tells us the number of electrons in the outermost shell. Let's take, for example, carbon. Carbon has 4 electrons in its outermost shell. And therefore, carbon and other group 4 elements, they neither give away nor do they accept. What elements in group 4 tend to do is they tend to share electrons through covalent bonding. So basically, we have our metals forming cations and our nonmetals forming anions. Group 8, as we mentioned before, are the noble gases, and these already have their outermost shells filled, so they do not participate in bonding. So I hope that you can now write the electronic configuration of all of your atoms from 1 to 20 in the periodic table, as well as the electronic configuration of the ions that are formed by our metals as well as our nonmetals. So that's all for today. I'll see you in the next video.